Section 4.6 continues very closely for what we did in sections 4.3, 4.4, and 4.5, where we looked at our 5 different types of congruences. If you're still not real certain on identifying those types, it may be good to go back and watch that video first before going to this section, because it is heavily based on what we did there. To kind of give us a quick check, we have 3 examples on the bottom. We need to see if we can determine they're congruent and what we would use. So if I look at this first one, I have 2 sets of sides already. AB and DB are congruent, AC and DC are congruent. Now by reflexive property, I also get that BC is congruent to itself. It is in both triangles, so these 2 triangles would be congruent by side, side, side. On our second one, we again have KJ and KL are congruent. We have a right angle at M, and since it's a linear pair, we also have a right angle on that side as well. So we have 2 right angles in each triangle. We also have congruent angles in the triangles. We can think of them as either way. We have reflexive property again, so now it's identifying it. It's not going to be angle side side. That one does not work. But since we have those right angles, that should have reminded us that it could be hypotenuse leg. If we look, KJ and KL are hypotenuses. They're opposite the right angles. And then I have a congruent leg, which is KM, so it's going to be HL. Our last one here, I have 2 triangles that are overlapping. Anytime I see that, I want to draw the 2 triangles separately. So if I pull them apart, I have KLG, HJN. I didn't copy over point M because point M isn't really a vertex or a angle in any of those triangles, so that one really doesn't help me. Now I mark what I know. I have H and G are congruent. I have N and L are congruent, and I have LK is congruent to JN. Now I can look at them separately and see I have 2 angles and a side. The side is not between the angles, so it is angle, angle, side. So some good review to us before we start this actual section. So in 4.6 we get a new term, which is corresponding parts of congruent triangles are congruent. We shorten that up and just use the abbreviation CPCTC. So let's kind of work through the process that we've done so far this chapter. If we start in that very first spot, we're given a diagram, a problem, a proof. We're given something to start with. And I have that in my 2 triangles here, ADC and ABC. So we have to figure out how they are congruent. And I can look at it and I'm given some information. So sometimes we get givens. Well, we typically get givens, we should say. And I would look at this one and say, well, you know, AC is reflexive, and reflexive is another property that does come up. And if I did that, I could start to see the different things that work. Now, before we go on to this specific example, let's list some other things that do show up that we should be aware of, kind of a strategy of tools we could use. Reflexive is very popular. Vertical angles. We also sometimes see midpoint. We may have parallel lines, and those usually lead to alternate interior angles or corresponding angles. We may have right angles like we had here, but we typically see that the right angles are on both sides. And those are the things you need to look for. Those are the things you take from the diagram that you can usually add to it to finish the problem. But this is where we start. We get the diagram and we find the information we know and what else we can pull from the diagram. Then once we have that, we can then show the triangles are congruent, like we did in this case. So we show they're congruent. So I say ADC is congruent to ABC. In this case, it is hypotenuse leg for this specific example, but we also have side, 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 angle, side, angle, side, angle, and angle, angle, side. So those are our 5 we have. So again, we've started in that beginning step. We had some given, something else. We then went to our 5 ways to show they're congruent, and that's kind of where we stopped. So where this new section lets us go is to the end where we have CPCTC, or corresponding parts of congruent triangles, are congruent. And what we're saying here is, since we know the triangles are congruent, we had enough with those 5 congruences to get the triangles are congruent. That means all of the other corresponding parts are congruent. Well, all of the other parts. Well, let's look back at our original diagram. We didn't list anything about CD being congruent to BC. I'll say CB. We didn't say anything about angle D congruent to angle B. And DAC congruent to BAC. But since we know the 2 triangles are congruent, we know all the other parts are congruent. The rest of it also is included. So we had that minimum amount of information to get us to the second step to say they're congruent. And now once the triangles are congruent, they're all the parts. All the corresponding parts are congruent, or we should say the corresponding parts of our congruent triangles are congruent. So let's look at a proof and see how we really use it. And you're also going to notice how it's not very different than what we've already been doing with our proofs. So explain how you can prove that angle A is congruent to angle C. Instead of explain, we're just going to do the proof, and that'll kind of help us work through the process. So 2-column proof. Let's start with what we're given. So I know that AD is congruent to CD, and AB is congruent to CB. These are both given. Now I also have a reflexive there. That's BD is congruent to itself, and it's in both triangles. So BD is congruent to BD. Better mark that. And now I look at my 2 triangles, and I see that they are congruent by side, side, side. So I could say that triangle ABD is congruent to triangle CBD. Okay, so that's what we could have done last chapter. That's where we could have left off. But now we have to look at, why is A congruent to C? Well, we know side, side, side gives us triangle congruence. So, because the 2 triangles are congruent, I can now say that angle A is congruent to angle C because the corresponding parts, that's A and C, of congruent triangles, that's what we have above, are congruent. So we had that last extra step to say that corresponding parts are also congruent. I could have also said the same thing about the angles that are at B and the angles that are at D. It's just the stuff we didn't have marked, we can now add them all because of the corresponding parts of congruent triangles being congruent. Let's look at another example. So here we have a picture where we want to find the distance across the canyon. So let's draw in. We want to figure out how far it is across the canyon. It's a long way. Maybe we don't have that dam there and we want to figure out how far it is across. So we do have congruent triangles here. And now we have to see what makes them congruent. But if we can show that, then we can probably show that the other parts match up as well. So I've taken, it's a little difficult to see in that diagram, what we already knew. And that is BD is congruent to BD. And angle C and angle D are both right angles, so they're also congruent. Now, by this diagram, I can also see I'm going to have vertical angles at the vertex B. So we're kind of getting ahead of ourselves. Let's write this stuff down. So I know that BC is congruent to BD. I have that angle C is congruent to angle D, and that's because they're right angles. I have that both angles at B, so we want to say ABC is congruent to EBD because they're vertical. Oops, I forgot a letter. So now I'm looking at these 2 triangles, but wait, I can show these 2 triangles are congruent. I can say that ABC is congruent to triangle EBD by one of our congruences. I have angle, side, angle. And that's what I get from this part right here. I get enough of that information from that little part. Yeah, I don't know anything that's going on out at A and E, but I have enough at those parts to help me out. Now that we have our two triangles congruent, we can now see what we know about AC. So by what we've talked about with CPCTC, we have that the two triangles are congruent by angle, side, angle. So that means now that AC is going to be congruent to DE because of the CPCTC. So because we have that the corresponding parts in those congruent triangles are the same, to fit the context of the problem, we could figure out how far across the canyon is by looking at the distance from D to E. Same thing if we want to know how far it was from A to B. Although it's not the distance across the canyon, it is some length, we could use the corresponding parts. Or even if we wanted to know the angles A and E, what their measures were. If we knew one, we know the other because those parts match up.